Everyone. We continue where we stopped. So we stopped with intelligent techniques, and artificial intelligence is one of them. So what do we mean by artificial intelligence? So from its name, uh, it is actually started in 19, or it was defined in 1950 by a scientist called Alan Turing, and he defined artificial intelligence or AI as a system conversing, or when you converse with a system, and you as a human, you will not be able to distinguish whether you are conversing with a system or with a human being. So in other words, so artificial intelligence is trying to imitate the smartness or the 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 way the humans think and act, right? We want the system to be as smart as the human being or even smarter than the human being, right? So the grand vision is actually to have this hardware and software system that are as smart as humans and they think and act like humans, right? Unfortunately, so far, this vision has not been accomplished, although some might argue that ChatGPT has been there with this grand vision to think and act like humans. But still, we can say that AI is going to 100% replace humans, as there are several jobs that require humans, and we will talk about that in a little bit, right? Although artificial intelligence can do certain jobs better than humans, of course, for sure. However, deep machine learning is close to achieve this grand vision, which is ChatGPT is part of that deep machine learning. We'll talk about it in a little bit. So another one definition of artificial intelligence is systems that can take data inputs and then they process this data input and produce output. So garbage in, process, garbage out, right? This is kind of the traditional software programming method that we usually use. So again, they can perform many complex tasks that could be difficult or impossible for humans to perform. So for example, the search engine in Google searches thousands, if not millions of websites in order to, and returns an answer within a millisecond. So a human being will not be able to do that in milliseconds. They will take days, if not years, to go through those websites to return that same answer. So there are major types of artificial intelligence, and we are going to talk about each one of them. So an expert systems, from its name, a system that tries to imitate the expertise of a human being and uses or captures the tacit knowledge of an individual expert, human expert, and captures that knowledge as a set of rules. So if then, I remember we one of the assignments that we worked in, or the hands-on exercise we worked in this class, was about issuing a loan for an individual, and we had some of the parameters. So, for example, if the individual has more than 20% down payment, right, or if their income to their debt percentage is exceeding certain percentage, right, or if they're or if they so there are different parameters that we have used as an example for an expert system, right? So now we use an if statement. So if then, if true, then it's going to be this, otherwise it's going to be that, right? So this is what we mean here by a set of rules, if then. And then typically perform limited tasks. And example is determining whether to grant a credit for a loan. And we use that, the expert system. And we need to have a knowledge base, which is a set of thousands or hundreds of or thousands of rules. So for example, so those expert systems or machine learning actually learn the same way that we learn. So for example, for us, when we wake up in the morning, for me, when I wake up in the morning, I look at the window. and I see if there is rain. If there is rain, and then I will take my umbrella or my rain jacket with me so I can go to work. So this is, if not, if it is not raining, I will not take my umbrella. So it is if, then, right? This is an example of rules. And we learned that. So I learned that from historical my past experiences. That's how actually the machine learns from historical experiences. What was the right thing to do, and what should be the right thing to do in the future. So for me, in the past, I saw that it was raining and I left without my umbrella or rain jacket. I ended up getting sick for a week and I didn't go to work. Then I learned a lesson from my past. So that way in the future, I can do the right thing. So the same thing for artificial intelligence, that's what it does. It learns from historical data and then it avoids those mistakes and does the right thing in the future when we feed it with future data. So for example, this is an example of flow chart. So for me, I remember I developed a software for the help desk, IT help desk at the university, at Emporia State University in Kansas, when I was a bachelor student in information systems. So what I did is I met with the director of the help desk or IT help desk, and I asked him to give me a flow chart of the most recurring issues or IT issues that they have, because they came to our class, our capstone class, and they said we wanted to create an expert system software where we can hire students from any background, whether they are music or any background, who can help us solve help desk IT problems, right? And those problems were, for example, problems with the printer, or problems with login credentials, or problems with the hardware of the computer. So one of the examples of the algorithms, which is a flow chart like this, that we used, he's the expert, he's the subject matter expert, and he put his knowledge or expertise in this flow chart format like this. So if the question is about, let's say, printer, then go do the printer process. So the printer process, the first question was, is the printer plugged in to an electric outlet, right? Is it plugged into to the internet if it is wireless, right, or wired, right? Is it plugged in? And then if it is yes, then we go to the next step. Check this, check that. So it is an if and then. So this is where we capture the human's expertise and put it into a flowchart algorithm, and then you convert or transform that into software. So machine learning, we all hear about machine learning. So from its name, the machine learns from historical data. It's just the same example that I gave about the umbrella. So for me, I look at the window, and why I decided to take an umbrella with me if it is raining is because of my past experience. When I go to work, I go outside without umbrella, I get wet and I get sick, right? And I don't want to repeat that negative experience, right? So the same thing for machine learning. It learns from historical data, so that way it can predict in the future and does the right decision for us in the future. And machine learning can be used by neural networks, deep learning, and genetic algorithms. They are different paradigm than the expert systems, and they focus on recognizing patterns in very large data sets. So in other words, machine learning, we train that machine. It learns by us training that machine learning algorithm, so it can do things for us. Examples of machine learning includes the Facebook ad display. So based on your historical data or clicks, likes, shares, and posts, then and videos that you click on and watch, it will display for you certain ads, right? That matches your interest. And then Netflix recommender system also, based on the videos that you have watched, based on features about you and people who are similar to you, right? Have features like you, for example, in terms of age, zip code, and so on. Then they can say, "Oh, you have watched this video." People who've watched this movie are also were also interested in watching this other movie. So this is what we mean by machine learning for our recommender system. And then within machine learning, we have supervised machine learning and we have unsupervised machine learning. So supervised machine learning, this is when we have examples about the input and output from the past. So for example, that we have customers in a bank in the past that have certain features. So those input or features about them, like their age, their income, their credit history, and so on. And then we already knew in the past whether they defaulted or not, right? We fed this training data set into our machine learning algorithm, and it learns from that input, which is the characteristics, and whether they defaulted or not in their loans. So that's already data in the past or examples in the past, right? So then when we have a new customer in the future, the algorithm looks at those parameters and those features, and it will spit out for us whether this person will default in their loan or not, based on what it learned from the historical data. So one example is, well, as I mentioned, is the default in the loan. And then we have the second type of machine learning is called unsupervised learning. So it uses same procedures as used in supervised learning, but humans do not provide examples. So we don't know a target. There is no target variable. So in the supervised learning, we already know what was our target variable, whether it is defaulting in the loan or not. In the unsupervised learning, we don't know a target variable yet. So examples of unsupervised learning is association rules, clustering, just kind of to name a few. And an example of association rules that I'd like to share with you is about a super center in the Midwest region of the United States decided to do unsupervised machine learning analysis using association rules. So they looked at the products that are associated with other product sales. So they realized, or they discovered, that the sales of baby diapers is associated with the sales of beer. So then they wondered what is the relationship between them. So they conducted diagnostic analytics. So where they went and they interviewed some of those individuals who bought beer and diapers. And they discovered from this diagnostic analytics that individuals who bought beer and diaper is because they have new babies. And in the past, after work, they would go to a bar and drink there. And then after they are done, they go home. But now they have new babies. They decided to go and buy diapers for them after work. And instead of going to a bar, they would buy a bag of beer and drink at home while they are enjoying their time with their baby. So this is a very interesting finding, right? It is knowledge that we know, but we need to apply it. How can we apply it to our goal or our bottom line? How we can increase profitability as a result of this, or monetize this knowledge, right? So we do that, or they decided that since people buy diapers, we are going to do product placement. So we will place the aisle for alcohol close to the baby diapers location. So now, if you notice, if you decided to go, or if you go to Walmart, this story is not about Walmart per se, but when you go to Walmart, go to the baby diaper. For me, I know where it is because I have a baby. So it is in the back wall. And then you will notice that the alcohol or the beer aisle is very close to it. So as a result of this product placement closer to each other, the sales of both products soared and went up. Again, that's increased profitability. So this is an example of unsupervised learning that I wanted to share with you. And then neural networks, that actually is one of the machine learning algorithms, and it helps finding patterns and relationships among massive amounts of data. And then it learns patterns by searching for relationships, building models and correcting over and over again, right? And again, we as humans, we train that model by feeding it data from historical data. And also we provided it with outputs, the target variables or the targets that are already known. And then it learns from that historical data so it can recognize and help us predict in the future. So neural network is used in medicine, science, business problems, in pattern classification, prediction, financial analysis, optimization, and self-driving cars actually use neural network. And Visa International also use neural network in order to detect if some of the credit card transactions are fraud or not, right? I remember one time I was driving through Austin and my credit card didn't work because they recognized that a few hours ago I was in Kansas, or in Kansas City, and all of a sudden, after a few hours, I am in Austin. So they thought maybe somebody stole my credit card, and they are actually shopping from in Austin. So that's great. So they sent me a text to just verify that was me. But that's a great way, and I was really happy with that, right? It prevented me from transacting because they thought somebody stole my credit card, and I like that. So this is what we mean here by neural network. We have several. We have the input layer, hidden layer, and output layer, right? And neural network, as part of it, is the deep learning neural network. Right? Deep learning neural network is similar to what is evolution or neural network on steroid, right? But it has multiple layers. So instead of having here one or hidden layer, it has multiple layers of transformations of input data to produce target output. And it is used to detect patterns, unsupervised learning mainly. Some believe those come closest to the grand vision of AI, right? The deep learning. And this is an example of the multiple layers that deep learning uses. So limitations of neural networks and machine learning, that it requires a large data sets to identify patterns, right? And patterns might not make sense, and they might be only temporal. They might work in certain times, but not all the time. And also how systems arrived at a particular solution often is not explained. So now there is a trend in terms of research, and I actually have a research paper that is working on explainable AI or explainable artificial intelligence or explainable analytics. And that's very important because managers, they need to know what are the important features and how the neural network or that machine learning algorithm came to that conclusion, right? Or to that decision. So it is mostly useful for binary categories like yes or no, but now there are some algorithms that support so this is one of their limitations, as the book mentions. And another limitation is there is no sense of ethics when it comes to machine learning, right? Therefore, machine learning will not replace humans. We still need to have managers who can make that call about illegal or immoral or ethical decisions, right? So still, they will not be able to replace managers. And that's one thing that I always repeat, and I want to repeat again here. So AI will replace your job if you don't learn AI. So keep that in mind. AI will replace your job if you don't learn AI. So it is complementary rather than competing with humans. So you need to learn it, how you can use it to increase your productivity. Otherwise, it is going to replace you. So genetic algorithms, again, it's useful for optimization problems. So it's a form of machine learning, and it is based on the process of evolution. So it takes into consideration the inheritance, mutation, and selection. So it is used again for optimization problems. So for example, minimization of the cost, efficient scheduling, and it is based on hundreds or thousands of variables. So remember one time we talked about previous lecture, we talked about how that shipping company uses a system, an optimization system that optimizes the scheduling with the profitability, with the resources that are available. And that's an example of genetic algorithms, which is optimizing scheduling for shipping, for example. And then we have natural language processing. This is where we can use text mining. We can use voice mining, right? We can use text and voice commands using natural languages, and software can actually process those and recognize those. So they are based on machine learning and deep learning. Examples of natural language processing is Google search. Google Translate uses text that translates to other languages. Spam filtering systems, that's the naive Bayes machine learning algorithms that spots spam emails through text. And then text mining, sentiment analysis. Actually, in this class, we're going to conduct sentiment analysis for the text mining hands-on exercise that we will do towards the end of the semester. And also customer call center interactions. So then we can use chatbots in order to interact with customers and provide solutions to our customers. So computer vision systems, so from its name, it emulates the human vision system to view and extract information from real-world images. And examples of that is Facebook deepfakes, and you might have heard also about the deepfake, where they can actually show different people with different voices, different faces, and so on. But this is a feature that is used in Facebook, which is deepfakes. So this feature recognizes your picture, and then if someone posted a picture of you, then they give them an option or it recognizes you. It might even automatically tag you on that picture that you didn't have to go and tag yourself by yourself. It recognizes you automatically. And then autonomous vehicles also, they recognize signs, roads, markers, people, animals, and so on, right? But still, it's not 100% like autonomous vehicles. We have heard about a lot of accidents. So, for example, one time Tesla car was in the autopilot system, and then it crashed into a semi truck, and because it was blurry with the sunlight. So again, we are not 100% yet. Artificial intelligence is not 100% yet replacing humans. And then robotics, which deals with the movable machines. So design, construct, and operate movable machines. And they are programmed as if we are programming in C++, Java, Python, or R. Right? We use the programming for that, and robotics is used for jobs that are much done efficiently by robots rather than by humans. So, for example, by spray paint autos, it is very detail oriented. So robots might do it better than humans. Welding, that's a dangerous job. So it might be easier for robots than humans who might get hurt. Heavy assembly movement, again, dangerous situations like bomb disposal, delivering medical supplies, and surgical robots are expanding their capabilities in the brain surgeries and so on. And then intelligent agents, those are They work without direct human intervention to carry out repetitive and predictable tasks, like, for example, deleting junk email or finding cheapest airfare, right? That is used by Kayak or Google Flights, right? So some are capable of self-adjustment, like Siri. So, for example, when you buy your iPhone the first time, it takes you through a couple of questions. At least Siri takes you through a couple of questions, so it can learn your accent, can learn the way you say things. That way, it will understand you better. If somebody else with different accent comes to use your Siri, Siri might not understand them. So that's why, for me, I bought a car, for example, the other day, which is part of the chatbots. So in order to activate my voice, in my car, it asked me a couple of questions in order to recognize my accent, so that way I can communicate with that chatbot in my car, where I can command it, for example, or find me directions to Houston, or find me directions to the closest Chick-fil-A, right? So this is an example here of intelligent agents, and that is used in businesses. So, for example, a software agent, intelligent agent will schedule deliveries from suppliers. If a supplier cannot deliver, then they will try to find an alternative supplier. Same thing here for retailers. They will see if a retailer is short in certain stocks, and then they can order a restocking for them. In terms of distribution, also, that intelligent agents, software agents, will schedule shipment for distributors to retailers and giving priority for those whose inventory is very low. So you get the idea what we mean by intelligent agent, and I provided you with those videos, and I would advise you to go through this video in particular, which is the Canadian genius created modern AI. It's a very interesting video, and please have a look at it, and also have a look at the Watson videos over here. And I will stop here, and all the best. I will talk to you